This video is a part of the A to Z series of Python language where I go through all the built-in functions of Python starting with letter F with a description of how to use them. The imported library functions and classes are written using these built-in functions only. So you can consider this as a foundation of the entire Python language. If you have landed directly on this video, you can check out the entire playlist in the iCard above or through the link in the description. Otherwise, watch this video till the end as I will also give real project examples where these functions might be useful wherever I can. My name is Aditya Shenoy from Brainy where I make programming simple and fun. YouTube statistics show that a small percentage of you who watch my videos are actually subscribed to this channel, so if you end up liking this video, please consider subscribing. It's free and you can always change your mind in future. The first function is the filter function. It takes two parameters. The first parameter is the function used for filtering and second parameter is the iterable on which you want to apply this filter. To demonstrate this, I will create a filter. I will name it as even function and I will pass one parameter x that will contain the elements of the iterable, and inside this function I will return whether this x element is even or not, x mod 2 equal 0. So we have defined our filter function. Now we can call the filter function like this and pass the function name even like this. Make sure you don't pass the parentheses and just the function name over here, and I will pass an iterable on which I want to apply this filter on. So I will pass 1 2 3 4 5 6 like this, and when I run this cell I will get a filter object like this. We can easily convert this to a list like this, and as you can see all the even numbers are kept and all odd numbers are filtered out. That means if this filter function returns true, then only it will keep the elements in the final output. Instead of defining this function in a separate line, if you want to use this filter function only once, then you can use the lambda function instead of this entire defining of the function. So you will pass lambda keyword just like the definition keyword over here. You will pass the parameters, comma separated parameters. In this case we have just one parameter. I will pass a colon just like this, and after this I will add what is returned by this function. So this expression is returned, so I will paste it over here. So this entire lambda function is just the shorthand of the entire function I have written over here. Notice that this function is anonymous because it does not have any name to it, because technically we are just using this just once, so we don't need this function name. And if I run this cell, I will again get the same output 246 even after using the lambda function. There is also one more option available to filter elements out, that is the list comprehension. So suppose you have a list. I will copy the elements just as before, and if I want to print a new list which contains only even elements, so I will use list comprehension like this. So I want to print all x's which are present in A if x is even, and it will return the same output. So it is just a matter of choice of yours. What do you prefer most, whether you want to use this filter function or whether you want to use the list comprehension. It depends on the application where you are using this. Suppose the function, the filtering condition is very big, so you want to define a very big function to filter elements out, then you will definitely use filter function. But if the filtering condition is very small, then you might use list comprehension like this. This function has a lot of uses where you want to filter out the data in some data science application, or for some problems where you want to filter some elements of the array. The next function is the float function. If we don't pass any parameter to this function, it will return a default value of 0.0. We can pass any other object to this function provided it has the function defined in its class for float conversion. So you can pass strings to this function, which is very useful as you can initialize some special values using strings. So I will use float. I will pass a string plus 2.5 and it will return me a 2.5 value. The string takes an optional sign like this. I need not mention this is just an optional sign, and after this sign we have to pass the numeric value. You can use the float literal like this 2.5 to initialize a float value, which is very normal. So the real use of passing a string inside the float function is where we can initialize some special constants. So instead of a numeric value, if we pass a string of I and f or infinity like this, it will initialize a floating constant that is infinite. And you can also pass sign to this, so it will initialize minus infinity like this. And these floating values are special because Python will ensure that no number tested with infinity is greater than infinity and any number is not lesser than minus infinity. You can also use scientific notations to initialize float values. So float string 2e6. Here e stands for into 10 raised to. So this is 2 into 10 raised to 6. That is, it is 2 million. You can also pass decimal values like this 2e raised to minus 2, and that will add that many digits after the decimal point and then multiply it by this number. So 0.01 into 2 is 0.02. You can also create a custom class and define the float function to tell Python how to convert this object to float value. So I will again create a custom class, my class. I will initialize a constructor init. It will take one parameter string. I will initialize self.string is string, and next I will override the function of double underscore float double underscore. I will pass the self keyword and I will return the length of self.string like this, but length of a string is an integer object and not the floating value, so we need to convert this into float value. And now if I call float function and pass an object of my class, and inside this constructor I will just pass a string of my name, and if I run this it will return me 6.0, that is the length of my string. Float function is very useful to convert integers or strings to float values. Python allows using of literals like this, but conversion from one data type to another is a very useful thing. And also float provides some special constants like infinity and minus infinity, which are handy in many problems. The next function is the format function. This format function takes two parameters, the object that we need to format and the format specifier. So if I pass format any object, say 5, and the second parameter will be a string to specify the format. In this case I will keep it empty, and if I run this it will return me a string of this object. Nothing so special. New versions of Python allow using of f strings, which are very powerful and shorthand notation of the same format function. So you precede a letter f before the string and you pass a curly brace, and inside this you will specify the object that you want to pass like this, a colon, and then the format specifier that you will pass inside this string. So I will keep it empty and see what happens. So it will return me the same output. So these are just two different ways. You will need format function if you are using older versions of Python. Newer versions of Python might want to use this because it is more powerful, as you can use multiple curly braces inside the same f string. So for all the next examples I will use f string, but you can still use this format function instead of f string by passing the value to the left of the colon as the first parameter and the value to the right of the colon inside a string as the second parameter to the format function. For the next example, I will format the number 15, and if we pass an integer in the format specifier like this, it will return a string of that width. So in this case, the string here is of length 5. Originally this string was of 2 length, so it added extra 3 spaces to make it of length 5. But if the width specified is smaller than the actual width, then this width is ignored. So if I pass 1 over here, it will still return 15 because it will not truncate anything inside the string, and this will be ignored. So I will revert it to 15.5. But what if we don't want spaces to be the padding character? Like this. You can specify the padding character before the width. So I can specify 0 and it will pad the extra spaces with the 0 character. To specify padding characters other than 0, you need to specify the alignment of the string. So to right align the text, which is the default, but you will need it to specify custom padding characters, you will add greater than symbol, or to remember it better, arrow pointing to the right, like this. And it will return a string which is right aligned. But we wanted this character so that we can specify custom characters, custom padding characters. So before the alignment character, I will add any character, say A, and as you can see, the 15 object is right aligned over here, and the extra remaining spaces to the left are padded with the character A. To left align, you will need to give lesser than symbol, or to remember it better, an arrow pointing to the left, and it will align this string to the left and fill all the remaining characters to the right with the padding character A. To center align, you will use a caret character which is above the 6 number on your keyboard, like this, and it will try to align it in the center and fill remaining characters with the padding character. There is one more alignment character which is only useful if you specify the sign format. So let's see what are the sign options available inside the format function. By default, a positive number will not contain any sign and only negative numbers will contain signs, because as you might have seen, these numbers we have specified positive numbers and it does not contain any plus sign as such. So we can pass minus 15 and we can specify the sign minus, and I will again specify the width of the string as 5, and if I run this, it will return a string containing negative sign. But this is the default behavior because negative signs, negative numbers are displayed with negative character always. But if we specify the final option of the alignment character, that is equal to sign, like this, then the padding character will be inserted after the sign and before the numeric value, like this. As you can see, negative sign, some spaces, and then the numeric value. To show signs of negative numbers as well as positive numbers, you will give plus as the sign format, like this, and even if you specify positive numbers, it will carry the plus sign. You can remove the equal to sign to move this plus sign, And if you want negative numbers to show sign but positive number to have blank spaces, you will specify that using a space character in the sign format. So I will print 15 with a space as a sign format, and I will use the same format function for -15. And as you can see, there is one more space. Even if we have not specified the width, it has added that space instead of the plus sign, and for negative it has printed the default negative sign. To format numbers bigger than 1000, you will sometimes want to add 1000 separators. There are two options for this. One is the comma separation and other is the underscore. So I will initialize 1 million, 1 is 6 like this, and I will specify comma as the comma separator. I will copy this and paste it and change this comma separation to underscore separation. And as you can see that the numbers that are returned inside this string are comma separated and underscore separated. We have talked about the width of the numbers, but what about the precision of the number after the decimal point? To specify the precision of the number, you will use a dot and then precision digits count and then a character F to specify that this is a floating value. So to demonstrate this, I will again use the 1 million number, and inside the format specifier I will use dot 3f. That is, after decimal number I want 3 digits and it should be a floating number. And as you can see, it has given me 3 digits after decimal. If we don't specify this, by default it will have 6 digits of accuracy. If we specify the width as well as the precision like this 6.3f, then you might notice that this 6 is not the width of the digits preceding dot, but it is the width of the entire string. So this 6 includes these 3 precision numbers as well as the decimal point, and then the rest of the numbers are padded with extra characters. For integer values, say 74, there are a bunch of options as the type formatter. If we pass a D like this, then it will return a normal decimal number. This is the default value because 74 is a decimal number and we are converting it to a decimal number, so this is the default value. I will copy this and paste it and change this format to binary. B stands for binary. So this number will be converted to 1001010, which is the binary representation of number 74. I will change this D to now X, which will have the hexadecimal number, and as I have specified smaller x, the alphabets that are used in the notation will also have lowercase alphabets. So if I pass capital X, it will have capital alphabets. I can also pass octal values like this. 112 is the base 8 representation of 74, and the final option that we have is the C. That is, the 74 Unicode number is converted to its corresponding character, which is capital J, and then it is printed. You can specify hashtag character to the binary, hexadecimal and octal numbers like this, hexadecimal and the octal characters, so that the string returns have the prefix 0b, 0x, 0 capital X and 0o to indicate that which base these numbers indicate. If the object is a float value, say 0.2, You have more options. You can specify small and capital E. E, copy this, change this to capital E, and as you can see, E stands for scientific notation, so the value returned will be in the scientific notation like this, E -01, and if we pass capital E, then only the letter E gets changed. You can also specify F with the precision so that it has only that many characters or digits after the decimal point. And there is one more option of percent sign, and I will again pass 0.2, and in this case the object is multiplied by 100 and then printed over here, and a suffix of percentage sign is added at the end. Now what if you want to use all the format specifiers at once? So you can specify a combination of all the format specifiers we talked about like this. F, say I want to format 7400.0 because I want to format a floating value. The format specifier will start after the colon value. I want to use 0 as the padding character. Then I will use the equal to alignment character. I want the number to have positive sign as well. I want to show the hexadecimal, octal or binary prefix. I want the string to be of 10th length. I want the string to have comma as a thousand separator. The count of digits after the decimal point will be 2, and this is the floating value. And if I run this, as you can see, all the effects are added except for the hashtag, because hashtag works with only B, O, small x and capital X, but still we can use a combination of this like this: 0 padding, positive sign, comma separation, decimal and 2 precision, and 10 width. The order in which you will specify these format specifiers will be displayed on the screen. Format function or its equivalent F strings are very useful in competitive programming where the problem asks us to print the output in a specific format. Also, you might find this useful in many more applications where you have to format, say, currency with 1000 separators or display percentages, etc. The next function is the frozenset. It returns a set data structure which is immutable. That is, we cannot add or remove elements from this data structure once it is constructed. If we pass 0 parameters to this function, it returns an empty frozen set like this. If we pass an iterable, which can be list, set, tuples, or any other iterables that can be looped upon like this, 1153, then it returns a set data structure. As you might know, set data structures does not allow duplicate elements, and the order of the elements inside a set is not mandatory. So even if we have passed 153 in this order, the frozen set has 135, and this is just an arbitrary order. We cannot access this element using indices. So why would we use a frozen set instead of a set data structure? This function is useful when you want to have the set data structure as a key of a dictionary. Python dictionaries do not allow mutable data structures as the key. So instead of passing a set which is mutable, you can convert it to a frozen set which is immutable. This is the same for lists and tuples. Lists are mutable and tuples are not. So tuples can be used as the key of the dictionary. So these were all the built-in functions that start with letter F. If you ended up liking this video, please press that like button, comment any feedback that you have for this video or this channel, share this video with your friends. The code that I write in all my videos of this channel is available in my GitHub profile, whose link is in the description. You can connect to me via LinkedIn, whose link is again in the description, and I will see you in the next video.